Country Pickens Flea Market. Come on. We are in Missouri.
Point to it. Nice.
Yeah, and the outdoors. Yeah.
Yeah.
They want to see what you see. They want to see.
What is it? I can't see it. What is it? Oh, is it gold?
I don't know if that one's gold or not.
It's $150.
It must be.
Yes, ma'am. Had a lot of people look at that thing.
Something you want?
See.
I just need to pick up myself.
Diamond Chester?
Yeah.
Diamond.
Yeah, I'll get this.
All right, what'd you find here? What's this?
Well, a bunch more little jewelry.
Oh, just stuff hanging out. Look
Yeah,
at
this is just odd stuff.
I got you.
Yeah.
Find something magnificent.
Sterling silver. Sterling silver.
How about this stuff?
Yeah.
Sit down there, Teresa. What is that?
Yeah. Pretty pieces though.
How's that? Look at it. See if-
Silver plate.
Silver plated. Yeah, that's an old light pot. Used to light those on fire, and I put them around construction sites so you didn't fall down in any holes. Okay, these are 1/10, 18K gold fill. Yeah, this all looks like gold plated. I don't know, Trisha. What is this? See it?
Oh, costume.
This?
Yeah.
The box chain.
Yeah.
RGP is gold filled, but we're not gonna buy that. It's $85. It's gold plated.
I might look at that.
All right. Okay. There's some watches back here.
Yeah. You know what?
There's a bunch of Corning wire.
See one down there. That ruby one back there.
Okay.
That one you
Pull that
might
one
want.
in.
Yeah, that one you might want to look at. Okay.
With your glasses, it's $60.22.
All right. Sounds good.
Had
Well, I seen it was 150. I figured it might be something. I didn't know what it looked like. Silver,
But what was it?
gold.
How was you able to find that, Teresa? What made you think to look there and get it?
Because of my experience at it.
You could tell by looking, couldn't you?
Yeah.
Excellent.
Mm-hmm.
Gotta get it right on there without touching the metal.
I didn't touch the metal.
There you go. It's diamond.
Yeah. Good.
Nice.
Good?
Pretty good, isn't it?
Mm-hmm.
We're having us a picnic alongside I-55
Yeah.
in Missouri.
Tastes good.
Nothing like a lunch meat sandwich and some Doritos. Holy cow, 300. Not bad. You see that?
Yeah, you're not going to waste that money.
Nice. Welcome back to my channel, everyone. Sri Tips here. And we just returned from our trip. And we've got this material that we picked up on the way at some of the flea markets that we visited. This is the white gold ring with diamonds. And I think we paid 150 bucks for this thing. And it weighs 5.5 grams. You look here, I'm using Kitco Scrap It. I've got the value set for 100%. 5.5 grams of 14K is $266. We paid 150, I think it was, for that ring. It's a very nice ring. I may shine this up, buff it up. It's got diamonds in it, and offer this thing for sale on my eBay site. Next item we've got here that we purchased at that flea market is a 14K ring. It's got a synthetic emerald in it. Take that out of there. 14K gold. We paid 45 bucks for it. 1.1 grams of 14K is gonna be 1.1 is 53. So we're a little ahead on that one. The other item that I bought at that flea market was some gold-filled glasses. It's got a marking right there on the bridge. I think it says 18K gold-filled. And we'll just throw them aside, process them. Here's a couple more pairs of gold-filled glasses that I bought at another shop, a consignment shop. 2 pairs of gold-filled glasses. And what I'll do with I think I paid, she wanted 10 a piece, and I got them for $15 for both of those. We'll throw this in with our gold-filled stuff and process it. At that same shop, I got a gold-filled chain. It was, I think, $2. We'll throw that in with our gold-filled stuff. And then last, we picked this up at another shop. I can't remember exactly where this was, but she found these. These were $5, and they're 14K gold. So there's 1.1 grams of 14K. That's another pair that was $5. They are also 14K. So she got 1.9 grams of 14K gold for $10. Then she found this watch. I think it was $100. 95, something like that. It's 14K gold. These things are typically about 4 or 5 grams of gold in the case. The band is going to be gold filled, so we'll call it 4 grams of 14K plus, call that 2 grams just to interpolate between the two. So we got a total of 6 grams of 14K gold here. All right, 6 grams of 14K. We paid 10 and I think $100 bucks. So just say $110, and we've got 6 grams. Do the update. So we paid 110, and it's worth $290 according to this Kitco Scrap It. Oh yeah, I forgot about these. One other item here. These are some earrings that she found for 20 bucks. And if you notice here, they are diamond. Pretty nice sized diamonds too. Probably 1/10 of a carat. So we've got a set of 14K gold earrings with 2 1/10 carat diamonds. Pretty nice ones for 20 bucks. All right, for these glasses, you got some spring steel in here, and that stuff does not process well with the rest of the gold-filled stuff and nitric acid. So I cut them off and I save them. And then I'll take the lenses out and we'll put these frames in with this group of gold filled material that I've been accumulating. So we'll begin by taking all these spring steel pieces off of here. I save them, and I can process these separately, but they require some special treatments because the nitric won't dissolve that spring steel very well. I'll cut this thing up and put this in with this group of gold-filled stuff. It's got some pieces of pearl in here that I don't want in with the stuff that we're going to process. So I'm going to take those pieces of pearl off of there and exclude them. Here's our gold-filled material that we're going to process. Got a weight on the dish. Let's see what we got for a weight here. 1264, 1264 minus 912.5. So we've got 351.5 grams of gold-filled material that we're going to process. This is gold-filled material, and we get this in junk jewelry bags sometimes. Other times we find it at consignment shops and resale shops. And people don't think it's valuable because it's gold-filled. Gold-filled is a thick coating of karat gold over brass. And so for that reason, people don't believe it has any value. But in my experience, I can yield about 2.5 grams of pure gold for every 100 grams of gold-filled scrap when I do these refinings. I'm going to start this off by adding some distilled water to a 4-liter beaker back here. I like using a big beaker. I'm adding the gold-filled material to this melt dish here, and what we'll do is we'll burn it to remove any grease or oil. To redness, just to burn off any combustible material. Now we'll add this to our beaker. Put some more material in here. And heat the rest of this up to redness. Now we'll add that to the melt dish. To the beaker rather. I've got about 1/2 liter of distilled water in here on this gold-filled stuff. I'm going to set it on our heat source. Now what I'll do is add some nitric acid. Let's see, about maybe a couple hundred milliliters, just to get this thing started. And we'll just let it go without adding any heat. There'll be enough heat generated from the reaction. I'm going to make up some more dilute nitric here. And according to the amount of gold-filled scrap we had, should take about 1 liter of nitric acid to get all the base metals dissolved away from those gold foils. So I got 200, so I'm going to add 200 nitric. And now we'll add this into our metal in here. Should just go right on in now that we've got most of the base metals dissolved out. Should just be able to add this right on in. Save a little bit out. heat up now and let this boil. If you look down here, you can see that those gold foils are just shells of carat gold with the base metals removed from them. See that? That's just the carat gold is left behind because the nitric won't dissolve the carat gold. It just dissolves out the base metals, leaves these shells in the same shape of what they used to be. If this was a small batch, this shouldn't take that long. Should use about 1 liter of nitric acid. I think we've pretty much got all the base metals dissolved out of here. I'm going to pull this down off the heat now. We're going to allow this to cool off. There you can see the gold foils pretty much, and they've just fallen apart. The longer we spend here getting the base metals out of here with high dilute nitric acid, the easier the refining will be later on when we get this filtered out and get it some aqua regia. This has still got quite a bit of fumage going on in there, and I can see some bubbling down here. So I'm going to put this back up on the heat and continue to heat this for a little while longer. I've allowed this to boil for several more hours. Still got a little bit of fumes in there. I think we've got this conquered now. I'm going to pull it down off the heat and we'll let this cool off. I'm going to add just a touch of distilled water to dilute this and help cool it down a little bit. I've allowed this to settle completely overnight and the solution is cool now. So what we're going to do is pick this up and see if we can get a shot of what this looks like. It's going to be gold foils and gold mud down on the bottom of that beaker. So now what we're going to do is we're going to separate the liquid from those solids. I've got a 4-liter filter flask set up down here. And I've got a specially prepared filter that fits down inside of our Buckner funnel. So now we're going to filter the solids out of that solution. Stick a marker under the beaker to tilt it toward the front there so that the solution will come down to the front. Now that I've got the bulk of the liquid, the clarified liquid that was allowed to settle overnight, now that I've got that pulled through the filter, this is our foils and gold mud that we recovered with those nitric acid boils. So now what we can do is add that stuff to this filter and collect the solids that we've accumulated into the filter. That's our valuable material there. Purple mud and those gold foils. That is what is going to be valuable gold. Got all that blue liquid pulled off. So now what we'll do is gather up these foils like so and stick them in a melt dish. Here's what the gold foils look like down in the melt dish. And so what we'll do is we're going to go ahead and get the furnace out and incinerate this material before we go to the next step. I've got a piece of copper here. I'm going to stick this in this beaker. Now what I'll do is transfer the solution that we just filtered off of our gold fill material. I'm going to transfer this liquid, about 2 liters of it, into this beaker with the copper in it, and we're going to cement the silver and other precious metals that may be present out onto this piece of copper. Here you can see the silver is already starting to come out of solution. There's lots of excess nitrogen in there, so it's going to eat that copper up fairly quickly. But you can see the little bit of silver that's cementing out onto that copper. What we'll do now is just move it up here into the fume hood, because there's going to be some fumes given off from this. We'll just set this up here and let this cement out on that piece of copper. Our furnace is ready. Oh yeah, it's nice and hot in there. So now what we're going to do is grab our gold foils here. This is an important step to ensure a successful refining here, is to burn this material, incinerate it. We're going to do that in this furnace right now. Just going to stick this in there and let this burn for a few minutes. I've had it in there for about 15 minutes, and you can see it's nice and cherry red. So what we'll do now is just take it up and set it up here and let it cool off. Here we go. Here's our gold filled material. Has been incinerated. I'm going to add that now to this beaker. I'm adding hydrochloric acid. We're going to add about 250, 300 milliliters or so of hydrochloric acid. What we'll do is make some aqua regia in here. I've got nitric acid, and we're going to go with about 60 milliliters, which is way more than we need, but that's okay when we're going with this gold filled scrap. And what we'll do is add this right on in. Let's see if we can move this back a little bit. I'm going to add this right on in. I've got 2 reactions going on in here. I've got that silver reaction going on, Now I'm going to have the gold reaction going on. And these two, it's not a good idea to do both of these at once in the fume hood because they do not play well together. But I'm going to go ahead and do it. I'm going to pour in the nitric acid, form the aqua regia in there. I'm going to cover this up now. I'm going to set this up on some heat and start dissolving the gold foils. I've got this evaporated down, and I think I've got all the excess nitric driven off out of here, so I'm going to take it down off the heat. I've allowed it to cool for a little while, and now what we'll do is I'm going to cool it further by adding some ice. Here's a look at the junk that was in the funnel. Just a quick rinse. Let's get our funnel out of here. Transfer the liquid that's got our gold in it into a beaker, clean beaker, to set up for precipitation. Bottles of ferrous sulfate from a previous refining. I'm going to use that to precipitate the gold. This batch of stannous was outdated. It was 4 months old, so I'm going to make some fresh stannous chloride testing solution. All right, I've got some stannous chloride crystals here. Put a pile about that big. And we're going to add this now to our jar. I've got some pure tin shot. Add another about 1.5 grams or so of pure tin shot. We'll add that right on into the jar here. Now I'll add about 25 milliliters of water, distilled water, which is that level about right there. Here we go. Add about 1 milliliter of hydrochloric acid. Put the lid on. Shake it up. it's ready to use immediately. What we're going to do now is test it, make sure it's indicating properly. I have some platinum standard testing solution. It's 1 gram per liter concentration of platinum solution. Put a little bit of that on our piece of filter paper. Get in here and test it. It should turn orange when we put this stannous on there. And you can see that it does, in fact, indicate correctly. Now let's get a sample of our solution out of the beaker. Some of our freshly prepared stannous. And you can see that dark stain means we've got gold in solution. Okay, for this precipitation, I've got some ferrous sulfate solution from a previous refining. What we'll do is go ahead and just pour this right on in. We should be able to see the gold come out of solution. It won't be as dramatic as SMB. We should be able to see a brown cloud of gold form when I put in the ferrous sulfate. Here we go. Swirl. Get it mixed up real good. Or reach down in here with a piece of filter paper. Get another stannous test. See if we still need to add any more precipitant. And we're getting a stain there, which tells me that not all the gold has come out of solution. We've got some more ferrous sulfate right here. Do is just add some of this in now. This is a more concentrated solution, so this should get the rest of the gold to drop out for us. Okay, this is not quite as dramatic as the SO2 gas or the SMB precipitation, but you can see that there is gold down on the bottom of the beaker down there from the ferrous sulfate reacting with the chloroauric acid solution to form pure gold. Now let's get down in here and do another test. Make sure we got all the gold precipitated. And there you can see by that negative stannous test, all the gold has been precipitated. This gold settles out fairly quickly. The ferrous sulfate precipitated gold does. See it in there? It's pretty good. What we're going to do is pour off this waste solution now into our temporary waste container. Here's our gold. That's from our 350 grams of gold-filled scrap. I'm going to add some hydrochloric acid to the gold now. And hydrochloric acid does a better job of removing dissolved metals than just plain water does. What we'll do is we'll set this up on the heat now and give this a boil in hydrochloric acid. Okay, I got skimpy with the hydrochloric acid. I didn't put enough in there. And you'll see that there's little steam explosions and spattering gold all over the inside of the beaker. That's undesirable. I've got some up here on the top even. So what I need to do is put about twice as much hydrochloric acid in there as I've got to ensure that it doesn't do that. But if you notice, the color of the hydrochloric, or the color of the gold now has changed. It's now a nice brown caramel color, and that's what the hydrochloric acid oil does for us. Here you can see the gold spattered everywhere. Use hydrochloric acid to rinse it all back down into the beaker, off the sides of the beaker. This will cause loss of your metal if you don't watch it. It'll spatter the gold right on out of the beaker. It's fairly spectacular. Now what I'll do is add some water. Add up to 300 milliliter level. And what this will do is this will help get some of that acid off there. Acid could contain a little bit of dissolved metals, iron, because we used iron sulfate for this precipitation. So we'll boil it in a little bit of distilled water now. Okay, I don't know why this does it sometimes, and sometimes it does not. But this one is concentrating heat with the water boil also. So we'll pull this down, let it cool off, and pour off that waste liquid. Let's go ahead and pour this water boil off into our waste container. All right, and this gold right here is very pure. Okay, here's our pure gold powder. It looks spectacular. That gold right there is going to be 3/9 fine or better, just like it is. But I think what we're going to do is run this through another complete refining cycle to get this gold just as pure as we possibly can. So now what I'll do is add some hydrochloric acid. A couple 100 milliliters should do it. Adding a little bit of sulfuric acid. And this will take care of any lead that may be present, reacting with any lead in solution, forming lead sulfate, and we can filter it out 100%. Now what I'll do is I'm going to set this up on my heat source over here, and I'm going to slowly add small doses of nitric acid until we get all that gold to go in solution. I like doing it up on this heating source here because it's easy to see. I'm going to put it on time lapse and start adding nitric acid. Here we go. Got everything to dissolve. That took about, what was it, about 30 minutes, I guess, or something like that. just used 200 milliliters of hydrochloric acid and about 6 milliliters of nitric acid. We got all that gold to go in solution. So now we're going to pull it down and let it cool off. I've allowed this to cool completely, but I'm adding a couple of ice cubes here to help dilute it and cool it down even further, and to precipitate out any silver chloride that might be present. Shouldn't be any of that in here. This is the second refining. While I'm waiting for this to cool off, let's bring down this this silver that we've got in here. Take a look at this. I'm going to stir this up a little bit with a glass rod. Just take a look and see what we got going on in this beaker. Here you can see down on the bottom of this beaker, that's our precious metals. That's going to be silver. Might have a little pieces of copper mixed in with it right there. We'll get all that out of there, and then I'll collect this silver in another container, rinse it over and over until I get all that color off of there, and then we'll melt it up into shot and run that silver through the silver cell. The solution is crystal clear. Indicates we got some high purity gold here. If you look in the filter, we've got no residue in there of any kind. Another indication that we've got some high purity gold here. Get our gold solution out of the way here and get set up for the precipitation. Just going to move this out of the way. What I have here is some sulfuric acid in an equalized addition funnel. I'm going to drop the sulfuric acid down here on some slurry of SMB, generate SO2 gas. I'm going to go through this tube, bubble through our sulfuric acid, and then come out this tube into our glass delivery tube. Let's go ahead and start a little bit of acid flow down into our gas generator. This is sulfuric acid dripping on SMB, sodium metabisulfite, and what this will do is this will start making SO2 gas, and we're going to use SO2 gas to precipitate out our pure gold. Now let's add the gold solution to this clean beaker. Dilute the solution because this reaction happens best from a dilute solution. Okay, here we go. We're going to add the delivery tube and start bubbling our SO2 gas in our solution. I'm going to leave this go. I'm not going to put it on time lapse. What we'll do is just let this play out. Real time. SO2 gas is thought to produce the cleanest gold precipitation above adding the SMB directly into the gold solution. The gas is a much cleaner precipitation because there's no byproducts. If we put the SMB directly into that solution, then we have some byproducts, some sodium chloride and other things that will form from the SMB powder being added to the chloroauric acid solution. If you look up on top up there, you can see there's some gold forming up here already. And we've only been at this probably about 30, 45 seconds. There goes our color change. It's going completely colorless, which is amazing. Look at that. That's 10 grams of gold in that solution. Went completely colorless, which is one of the attractive features of using SO2 gas to precipitate out our pure gold. Now I'm just going to be quiet. I'm going to let this thing ride until we get all that gold precipitated out of that solution. Reach in here with a piece of filter paper. Let's get a status test and see where we're at with this. Oh yeah, we still got gold in the solution. See that? So we'll just let this continue to bubble until we get all that gold to precipitate. You can see a layer of gold has formed down here at the bottom of the beaker. See that down there? Let's get down in here and get another status test, see where we're at with this. Okay, we're done. All the gold has precipitated out of our solution. I'm going to reach back up here, turn off the acid flow to our gas generator. Now what we'll do is pull this delivery tube out of here. this tube back here so that we don't create a vacuum and pull the acid in our cooling flask back here back up into our gas generator. Now we're just going to let this settle out completely and get our pure gold out of this beaker. This is almost settled completely, but I think what I'm going to do is set the burner up back here, and we'll boil this liquid to drive off any excess SO2 that might be in there. See the gold down in there? It looks fantastic. We're going to boil this off, get it to settle down completely, and drive off any excess SO2 gas that may be present. I've got that to clear up pretty good, and I think I got all the SO2 gas cleared up out of there. Let's go ahead and pour this off into the waste container now. Okay, here's the pure gold. SO2 gas precipitation. Okay, what we're going to do now is I'm going to set this pan up on our heater. Here's our gold. I've got another pan that I'm going to set inside here, like so. And it's held up off the up off the bottom of this pan, so it's not in contact with it. I'm just going to add our gold to that right there, like so. And now I'm going to add some tap water to this inner pan. We're going to use a water bath to dry the gold off. Turn some heat on. What it'll do here is the water will heat up and then slowly dry off our gold. Gold seems to do a little bit better when I dry it before I do the melt. Got this gold dried off completely. Now what we're going to do is transfer it into a melt dish carefully. Oh yeah, this comes off really easy. Very nice, very nice. High purity gold. Now we're going to take the gold over to the melt table. We'll melt this up a nice gold bar carefully. Here's our little gold bar from our gold-filled material. High purity gold. Let's see what we got for a weight on this thing. I was expecting 8 to 10 grams. And we've got 12.3. All right, we got 12.3 divided by 351.5. So that's 3.4% pure gold from that gold-filled material. And that's pretty much typically what I get from this kind of scrap. So we'll take it. Okay, this will conclude the video. Thank you for watching.